Okay, let's take a look at this problem. Um, Plans to take off reach a level cruising altitude of h, okay, after a horizontal distance of 100 miles, and as shown in the following diagram. Find a polynomial flight path. But by the way, when I read this, automatically I see from this point right here, I see a line coming straight down here, and I think Pythagorean theorem. I don't know if that's going to be true here. We'll read on and see. Probably not. It says polynomial flight path. Okay, never mind what I just said. Find a polynomial flight of the form. Okay, so we got f of x is equal ax to the third plus bx squared plus cx plus d. By following steps a through d to determine the constants a. Okay, assume h is 7. 7. Okay. Use the fact that the plane is on the ground at x equals 0 to determine the value of d. Okay, so if it's on the ground here at x equals 0, um, then, excuse me, what's f of x? Okay, f of x would represent, doesn't say it, but that represents our height. So, if x is equal to 0, then our height, f of 0, plug 0 in for all these, we're going to have a times 0 to the third plus b times 0 squared plus c times 0 plus d. But f of 0, which is our y on our graph, is equal to 0 here. And then those drop away, so we get d is equal to 0. So that disappears. Okay, and that's where they get that. Use the fact that the path is horizontal at x equals 0. Path is horizontal. That is, f prime is equal to 0, determine the value of c. Okay, the f prime here kind of implies me to find derivative. So if I take derivative of this, f prime, take 3, put it out in front, we got 3ax squared. Take 2, put it out in front, and we got 2bx. And this would give us c, and then d would go to 0. Okay, that's our derivative. What else do they tell us? F prime of 0 is equal to 0. So if I were to plug 0 in for x, because they tell us f prime is 0. We got 3a times 0 squared plus 2b times 0 plus c. And f prime of 0, they specifically tell us, is equal to 0. So that'd be 0. These would drop away, and we get c is equal to 0. Okay, that's interesting. C. Use the fact that at x equals 100, the height is 7. So here, height is 7 at 100, and the path is horizontal in terms of values of a and b. Use the fact that at x equals 100, the height is 7, and the path is horizontal to determine values of a and b. Path is horizontal. That means our rate of change means it's leveled off, or you set the first derivative equal to 0. Okay, so we know d, c, and d. So basically those go away. So what we're dealing with is f of x is equal to ax to the third plus bx squared. Now if I find the derivative of this, it's going to give us 3ax squared plus 2bx. Now I'm going to factor or set that equal to 0. So 3ax squared plus 2bx equal to 0. Again, why we're setting that equal to 0 is because they tell us it's horizontal. I'm going to factor out x, and that gives us 3ax plus 2b equal to 0. Set each one of those equal to 0, so I got x equals 0, and I got 3ax plus 2b equal to 0. X equals 0, Doesn't make any sense. Well, does it? No, because x is 100. Okay, so that doesn't make any sense. For this one, take 2b over. And this is a challenging one. So the height is 7. So the point is that we're dealing with that right there is 107. So this is our x and this is our y. And if I solve this for x, so I divide both sides by 3a, we get this right here. And so if I know 100, because we know what it is at that point. X is equal to 100. So if I plug that in, let's see where that goes. Negative 2b over 3a. How does that help me find a and b from this? Path is horizontal, so it's leveled off there. Oh, maybe I can use the original function. Okay, it's starting to come together now. So if I look at this, I said this is the point that exists, which means f of x is 7. Is that just 7 or is it height and something? Miles, I guess. Okay. So I'll plug 7 in for the f of x, which is y, and then I got a times x, which is 100 to the third power, plus b times 100 squared. Where's my calculator? Carrot 3. And what in the world is that? That's 1 million. Okay. So we got 7 is equal to 1 million. A plus 10,000 B, and we got this, so I can multiply both sides by 3a, and that'd give us 300a equals negative 2b, and take that over. Okay, we said C and D drop away. Okay. And take negative 2b over, it becomes a positive 2b equals 0. So now, just seems hideous. This is 1 million A plus 10,000 B equals 7. Now if I want to eliminate the B, I'd multiply this by 5,000, negative 5,000. So that would give us negative 15, 5 zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Multiply this by negative 5,000. We get negative 10,000 B. And negative 5,000 times 0 is 0, so it drops away. And then we got 1 million plus 10,000 B equals 7. If I add these now, negative 500,000 These drop away, equals 7. So 7 would equal to, or A would equal to, just doesn't seem right. 7 divided by negative 500,000. Negative 1.4 e to the negative 5, which would mean negative. Move this 5 places to the left. And we got 1, 2, 3, 4, 1, 4 for A. Let's see if that's, what do you know? that's I wasn't sure. Now we want to plug this back in and solve for B. So you can plug it in anywhere. Plug it into here. So I got 300 times negative 0.00040 zeros, 1, 4, plus 2b equals 0. And you solve this down and that'll give you your b. And I think that's kind of the main part of that problem. Again, to summarize, after I found C and D with their guidance, then I had one function here. And then that gives me one equation right here once I plug in that given point. Now find the derivative, get it down to this point, solve for x. And at this point, if I get it in the proper form, this gives us our second equation. So we got our two equations, and that allows us to solve for A and B.